So I hope the screen will be available for you now.
Yeah, screen is visible, sir.
Okay, fine. And audibility is audible?
That is also fine.
Fine.
Good.
Okay. So I just recollect. Okay, what are the Mathematica code learned so far? So the past two sessions we have learned so many Mathematica codes. Okay, we just recollect them. The number one is the numerical value of any given expression, how to find out. So just put a question mark and then the details will be available and you can see some of the further details by clicking over here and then get information about how to use this capital N, which is giving a numerical value of a given expression and number of digit precision that you want that can also be altered and you can also see some details here what are the options that are available and you can click it back. If you put a double question mark, all will be available. If you put a single question mark, you will get a only limited thing and click it over there and you will get it and you can see the options and then other details related to this Mathematica code capital letter N. As I said, we have seen already up to 10 power 7 or 10 power 6 digits that have been generated. So number capability with respect to the mathematics is too high. So that's what we have seen. Next is the manipulate. Even for the number generation, we have done the manipulation. For example, pi we have generated 1000 digits, 10,000 digits, 10 power 6, 7 digits also. Each individual numbers also has been found by using the manipulate statement. So this is the second one which we have learned and the details connected to things are available and what are which you wanted to learn that you just click it over here and then try to, because we have learned the minimum thing what we need. Further details, further things whatever you wanted to do that can also be learned by clicking it over here, which gives the details about how to give the commands for manipulate. This is the most powerful thing that is available in mathematics. So I try to learn this as much as possible and explore its possibility of using in various contexts so that you will be really learning a lot and a lot by using these manipulative statements. When it comes to numbers, you have a real numbers are available here, real digits, integer digits also available. We have learned the real digits and what is the detail about the real digits that is given here. So it gives a list of digits in approximate real number x together with the number of digits that are left of the decimal point. So that also we have seen number of digits that are there to the first. So there are other options that are available under the real digits that can also be go to the tally that also we have used. We have seen that when you look at the birthday of pi. Okay, so tally is another important statement that can also be used and the details are given here. Short it, numbers can be shorted out. Tally and short both we have used together. So you remember that on the use of the pi and when you generate numbers, you are able to find out how many number of zeros, how many number of 1, how many number of 2, like that. It goes on up to 9 by using the tally and short. To string, again there we have used it. Gives a string corresponding to the printed form of expression in output form. This is a printed form which is available. Once you write, it is a string. So this is the different forms also that are available that can also be used. And you can drop some of the things after getting this string. You can drop. You can drop the n characters can be dropped. Minus n means at the end of it. The last things can be dropped and group them also. Nth, 10th, 15th, or 17th, if you want to drop, that can also be done. Or m to n can also be dropped. Like that, all options that are available. So this is for starting. This is at the end and in between a group of numbers that are a string you want to drop that can also be dropped and there are other options. Multiple lists are there, then you have the options that can also be used for dropping. This is the table forms and table which is given in the various form which we have already created certain tables. Okay, for generating after generating the data, and we can give a table form and table headings can be given. And you can make a grid form. There are various options that are available and all are given here. These are the help that are available that you can immediately go through them and then get the table the way which you wanted to have it. Integrate. You have a definite and indefinite integrals that are available, and depending on your use, just select the integration and perform the integration. Okay, and there are conditions that are available. That conditions also can be, which is coming under the assumptions. Okay, that assumptions can also be used to when you depending on the integrand. Okay, this is for the integration. D also we have seen differentiation. For example, I wanted to have nth differentiation of the function. So just put with respect to x n times. So this is what the meaning of that. So like that, D can also perform, and you can have a partial derivative is also possible. Okay, vector derivative is also possible. You have array that can also be differentiated. Plot we have seen. Of course, this is again the most powerful thing that one should be explored. And there are several options that are available. We have seen some of the options.
Sir,
There are many more
integrate, sir, integrate that symbol, how to get that you didn't mention, I think.
That is very simple to use. Put an escape, okay, IN then close it. You are getting it. See, just follow. Press escape. You can try now, right now on your screen. All of you should try this. Because here have to try to do it on the screen.
Yes, sir. Yes, sir.
Okay, escape. Small I N T, then escape again. You press it, you will get it. Now the box for integrand, and this is for the variable. Suppose if it is an indefinite integral, again press escape. Put IN. The definite, now it's a definite integral. What we are given is indefinite integral. DI, sorry, that something is happening here. Okay, DIN DT escape. Now we get the limits on the lower limit, upper limit also available. If you have any problem, you can do like this also, not a problem. Okay, you can, this is equivalent. There's no difference between this and this. This is the standard forms. This is the standard form, and this can also be given in a traditional form also. Okay, that will be different, but you don't have to worry about learning all those. Either make it integrate as an x, but if you do this one, it's called a definite integral because we know x varying from x minimum to x maximum. That is equivalent to this. Okay, so it's possible for you to use the key or keyboard also to have this integrand symbols. Similarly, D also can be done. Okay, similarly D. See, for example, he has given a del. So that's also possible to do that. And if you find a difficulty in getting them also, please go to the palettes. Okay, writing assignments. So we have an integrate. See here. This is what. See here. Escape INTT and escape. Right? Are you able to see on the screen?
Yes, sir. Yes, sir.
Here it is again, same thing, but DINTT. This is summations. Then you can see the sum T, sum total. Escape, SUMT, if you put it, you will get this one. So every one of them is given the corresponding. See, for example, you can see the differentiation here. Partial differentiation, escape PD, escape. And this one, escape, DD, escape. So all, if you don't remember these things, you just come to these palettes and make sure that you are able to do all this kind of a thing, whatever it you want. Okay, under this you have the symbols, all the other mathematical thing which is required for you to use in symbol form, and then you have the arrows. So this is the setting things that are available. Similarly, if you go to the palettes and the basic things, you can see here. These are some of the basic things that are available. Okay, then there are text that can tan h, cos h, sin h, various things which is available for you to use them. So it's not a difficult thing for you to put it in this form. Only thing you just try to remember this, and remember that palettes should be used. Okay, and then when you start using the palettes, you always look for the keyboard entry because that will be much faster. Okay, for example, I want to have a square root. If I type something, for example, I want to have a square root of this number. So what you do, you have entered it. So if I select this and if I press Control 2, I'm getting a square root of that. That's what the square root of, you can see here, Control 2. It's available. So therefore, you can explore all these things as and when you start using it. And once you start using it, then you will remember that partly you will recollect it. Mostly you will be recollecting it. Not a difficult thing at all. So therefore, it is easy for you to get them automatically from the palettes. Okay. Now this is D, differentiation. Plots, as I said, you have so much of options that are available. If you wanted to see those options, just click here and then you go to the plot, probably here, local, web. Well, I just checked it. It is coming here. And probably you can see here options. 110 options that are available. Okay. See the number of options. You don't even use all of them, but learn whatever which is minimal required for you to present your figures as elegant as possible. Okay. So these are the options that are available under this plot. In addition to that, there are many other things. Okay. There are various other things also that are available. That also you can see some of the application he has given, some 19 applications, basic application, highlighting the continuous function features, complex valued function, then the equation solutions, property relation, some neat example. See, this is a very neat example, which is the most effective way of presenting a, I know what it is. You know what this is? Can you guess?
Hydrogen atom.
No. Harmonic
Yeah,
oscillator.
single harmonic oscillator. Yeah, Hermite
No.
polynomial.
Quantum harmonic oscillator. There you have the ground state, and you can see the n equal to 1, n equal to 0, starting from 1, 2, 3, 4, 5, 6, 7, 8. All of them are able to generated on this x square potential, this harmonic quantum harmonic potential, and that is being generated just by using two lines. Okay, you can see this is the exponential ground state. There are, and when n equal to 2, you have the second 3, 4, 5, 6, 7, 8 of them are available. It is very simple. Define the function with the Hermite, which is already available. And this is the weight function for the Hermite, for a Hermite polynomial. If you add this weight function with the normalization constants, then this becomes a wave function. Okay, the ABS value has been taken. That has been plotted here. So nice to see. And two lines. Evaluate this, and we have this. That's the power of this tool. Okay, it's being generated here and given. So this is a very neat example that is available under that. And you can have in your own functions, even for a hydrogen atom like this, you can generate, where you will use a Hermite. Here, Hermite, there you have a larger polynomial. And what is this statement which is available here in the Mathematica code for a Hermite H? That if you want to know about it, you just, as I said earlier, just put a question mark and copy that, then put it over here. Hermite. So this is what your Hermite function. This is a Hermite polynomial, which is the solution to the Hermite differential equation. You can see the polynomial, 10th polynomial of the Hermite. That is not same as the quantum harmonic oscillator. You have to add the weight function and other things. Normalization constant does. So you can do, you play with these things. Okay. You can have 100th Hermite, 200. So it's not a problem at all. Okay. You try here, for example, this is half n. It's 10th polynomial. If you want to have 100th polynomial, you can just put it there and you can see here. These are 100 polynomial of the happen. Okay. 98 x power 100. Okay, the numbers are generated. So fantastic to see. Okay. You will see them with all these constants that are available. So any of them which you would like to see, 50th, what is that you want to see? Okay. This is what the 50th polynomial of the Hermite. They're all very much useful in different places, this Hermite polynomials. Okay. So like this, you can explore them, then try to understand them and use it for a particular problem in which you are going to work. Okay, and then there are other scope applications, general extension, properties in relation, possible uses, and some neat example. They need example which he has given it, and then there are more than one of them. Interpolation between Hermite polynomials and your classical and the quantum. Okay. This is what the rest we have, and then this is something again connected to the parametric plot of this Hermite polynomial. So that is between what? E power minus h square square root n, e power minus. Okay, m and n. They are all orthogonal polynomials. No? So they are all orthogonal polynomials. Okay, therefore you would see the orthogonal property that can be there. You know what is the orthogonal property? What is the orthogonal property? So they are polynomial. 50 and 51 integrate. So it becomes
0.
Yeah, that's the orthogonal property. So these are orthogonal functions. Beauty of this, these are all orthogonal functions. So it is such a complex function, but still, if I take 50 and 51 integrate it, okay, they goes to 0. But if I take 50 square it, I have with the weight function, it become a 50th eigen state of a quantum harmonic oscillator. Okay, so that's how this is being learned here. You're having a plot with various things that are available. That options you can explore it. List plot again, if you have a data set, okay, you can plot them. Multiple data sets also can be plotted. So data 1, data 2, that also can be plotted. This will be extremely useful when you do this analysis of data, where you will be handling the numbers in pair, or you can have multiple numbers. In fact, I wanted to show you a number which I usually show it to people now. Where is it? I'll show you that how typical data that it can be handled by this profile. Data, very, very complicated things that are available to show. Yeah. Okay, I'll take something like this. This is the data here. See, these two are same numbers. One is the temperature, other one is some parameter connected to the sample. Other things are frequency, log f, epsilon prime, epsilon double is the dielectric factor, and the conduction. And these are the units that you have. You can see 1, 2, 3, 4, 5, 6 data in each set. Okay. You're able to see that these data that are there in this. And okay, so now you can see how many such 6 sets are available that can be obtained through this. It has, we have defined this equal to. So now you can see this data will go on forever. Okay, going on and on. You can see the number of data. Yeah. Okay, so this is the number of data points. So now I'll enter this. Shift enter this alone. Then I just look for the name of the file, name of the data set, go back to the home, take out this, then come back to the data where you wanted to count or see the numbers, get it down. Yeah, going on. So I'll take this name, which is copied over there, and ask for the length of it. Length of the data. Okay. This is the length. 1101 set of data I have, and each one has 1, 2, 3, 4, 5, 6, 7. So into 7. This many number of data that are available that should be handled. It can be handled comfortably. It can be handled. 7,707 data that are available. Okay. Okay. At least 2 of them will have same all throughout, whereas all other numbers are different. And it is actually the frequency which is incremented starting from 1 hertz to 10 power 11 hertz. That's what the meaning of this data. These data can be handled comfortably. Okay. And this is what is being done here. And I can locate each one of them. And what are the data which I wanted to take it out through this name, I can operate. Okay, I'm taking the 4th set of data, which is the quadrant quantity, and then other one, which is 6th one. Okay, and then here it is 5th one and 4th one. This is 4th one, and then certain combination that I multiply with certain factors. That is being done. That is being used here, and this is being plotted here. See, for example, this 4th data of each one of them, which means this is 1107 data. I don't want to plot all of them. If you plot it, it will be almost a continuous line. Okay, but when I do the fitting, I will use all the 1100 data. I don't want to miss any of the data. Okay, I will take all the data, but when I'm showing it, I will show it only this skipping by each by 10, which means divide by 10. So that is what the number of data which is shown here. So which means I have this number here, length of the data, and this you divide by 10 because I'm skipping each one of them. So which means I have something like 101, 110 data points that are available here to show it in the plot. Correct? So let me plot it now. And this is the list plot because the data set is available and I have selected the pair. And during the selection, I did something also. What I did is I have taken the log of this 6th one. And this I have taken as it is because of that already with me, taken as a log. Okay. This is already available as a log and this is taken as a log. This is the log plot of this. That is how it's being handled. So if you enter like this, this is what you'll get. Suppose if I remove this 10, now you see it's almost continuous. The data become continuous because you have a huge number of data that you don't have even the spacing. Okay, spacing cannot be seen. And if you wanted to see the spacing, what you can do is I'll subtract something like 1000 or 900 data, so I'll subtract it. See? I separated the 900 data and only the region of 10 power 2 or 2 10 power 2 I have shown. In this, again, I wanted to see only in steps of 2 or in steps of 5. That is the data which you have. So, going as 900. Or if I wanted to start from somewhere else, see 900 data at the end has been removed. And if I wanted to start somewhere here, let it be here. I wanted to start from say 500 data. Okay, I'm starting from 10 power 5 onwards to 10 power 11. Remaining I removed it. Okay, if I put all of them here, start from here. In between data, I wanted to stop it. So you can use a statement like this. I have this is not available for me. I can use this close star, then close this star. Say for example, let me take a huge gap of somewhere at the end, and then we continue. The bracket is here, comma is here, and I should continue. I close this somewhere. The close text. Okay, this is the data which will not be available for you to use. So now you can find out the number of data that is getting reduced from 1078 data only. And if I plot it all of them, I would see there's going to be a gap here. You see this gap here. So wherever you wanted to drop it, you can drop it, you can add it, and addition also possible. Join with the other data set, you can bring it here and join. So all possible options that have been given to you. Only thing you should learn them how to do it. It is very easy because this is treated like a matrix. Okay, this is actually 7 by 1101 matrix. That's what it means. Okay, where is the star? Here, I removed it. So if you look at this, I'll enter here. It should be entered. This is equal to 7 by 1101 matrix. Like I can locate every one of the data through these numbers. That is what being done. These double brackets. Okay, I'm changing the I values. So that's how it has been taken it out. First set, second set, and third set of data that has been taken, or you can get it from these things to this set also. The data conversion problem that I have something I have written important. So now you make a plot again, you get it. Now you can use this data to fit the data that you have here. Okay. You can take either full data or partial data and check it. And if you are not satisfied with that, I think I have taken full data for fitting do the fitting now. Find fit, nonlinear fit, and extract parameters. Okay, and then take the function with the data, you plot them. And if you have a multiple function, each one of the multiple function can also be seen. And you can have the other way of representing the data. It's also possible. So you can have things like this. I can show that one of the curve which is going like this, and the other one is a line, and the other one is a red one, which is going like this. There is another curve which is there, and some of these curves are this green one. That's what here. You can see here. It contains function 1, function 2, and then function 3. And individual function has been taken. I'm trying to show them. And then I have created with the fitted data with an option to change it. Each parameter, I have an option to change and see what is the consequence of this variation of the fit parameter. Okay, do they give any meaningful information or not? Are they physically valid or not? Okay, I'm able to see the consequence of each one of them. You can break the function into pieces and then try to analyze them. Then do something on this system. Okay. These are another parameters we have. And same thing can be done with the other plots. Here's another plot. Okay, here's another plot. So like this is possible for you to analyze. So data capabilities are amazing. So you should be in a position to learn them and use it. And I'm 100% sure the fitting this much comfortability, you don't get it any of the, even the software specially prepared for that also you cannot have it. But once you master it, then you don't feel like using any of the other softwares. You can use it your own programs that will do a wonderful job. Okay, so therefore, data capabilities are enormous with this Mathematica. Okay, so therefore, just the plot data handling should be taken care of. Now you have the parametric plot. What does it parameter? One function against the other function. Make a plot. I already shown you the sin theta versus cos theta, which you are going to see now after some time. Okay, and this is the parametric plot. You can have a multiple parametric plots also for.
So there are many fitting fit and fit.
Yeah. You have a fit, find fit, linear linear fit, non-linear fit, all are available. Okay, what is that you want to clarify?
What are the differences generally?
Each
Which
one is
one?
meant for certain purpose. Each one. Well, I think already no, I think I have not started this fitting no, so far. No, not yet. See, I'll explain it during the fitting when you learn the fitting part. Now we have a numerical method, no? Fitting, fitting. At that time, I'll
Yeah, yeah.
explain one by one. So what do you do with the fit? What do you do with the fine fit? Non-linear fit, linear fit, okay? All these things that are available, and all those things meant for certain purpose. When you have a simple expressions like what you have with the simple polynomial fit, okay? When you have a polynomial fit, you can use the simple fine fit, or just fitting a data alone. You do the fit, then do the data fitting. Suppose you have a complicated fit like what you have here, what I have shown, then you have to have a nonlinear fit, which doesn't necessarily mean nonlinear should be called. Okay, if we can manage with the linear, linear is enough. So all that are available that can be explored, and we should know the idea that mathematical idea that is behind fitting. Okay, that should also be least square minimization. What do you mean by least square minimization? That one should understand. So we'll learn little bit on that and then try to do all these methods with each one of them particular exam. Okay, there are many ways to do it, and that can be learned during the fitting procedures. Okay. So the parametric plot, as I said, you are plotting function against another function, which we have already seen. Some simple plots we have done it. Okay, for example, position and velocity plot. Okay, position and velocity. Projectile motion, if you have x component and y component, if I make a plot of x versus y, you'll get the path of the projectile. Or you can have eliminate the time dependent variable, then you will get an x and y. X is a function of y, or y is a function of x, that can also be seen. So you learn that all those things. Now, when you have a plots, multiple plots that are available, you can use this show. And there are other purposes also, not only for graphics, there are other things can also be shown. The graphics, whatever you have, that also can be used to show multiple plots when you make it, which we have already seen. No, do you remember that we have done it displacement, velocity, acceleration together by using a show?
Yeah, okay. Yeah.
And the dot also we have seen, that list plot also we have added under the show. The two dots which we have shown, no, that but that is moving on the displacement dot. Derivative at that point we have taken, that is also added along with the show. 5 curves, 10 curves, 15 curves, hundreds of curves, all can be shown together. So it's possible to combine the graphics. For that purpose, we use a show. Double question mark equal. You should understand this by reading this and then practice it. Make sure that you have a clear-cut picture about what do you mean by equal. Right hand, left hand side equal to right hand. Evaluate the right hand side and assign the result to be the value of left hand side. From then on, left hand side is replaced by right hand whenever it appears. Whenever it appears, that will be replaced. That's what is there. And I can have a list of left hand side equal to list of right hand side, which means L1 equal to R1, L2 equal to R2. This is one of the most powerful things that can also be used often if there is a requirement. I can have a list on the left hand side, need not be a one single variable. I can have an n number of variables, put it in the list, and then n number of variables on the other side also. I can connect one to one. It will be get connected to the one to one. If I call L1, which means I'll get an R1, L2, R2. That's how it's being used. So this is equal. Here dot equal, you can see assigns the left hand side to be delayed value of LHS. Right hand side is maintained in an unevaluated form. It will be, after doing it, it is again available in an unevaluated form. When left hand side appears, it is replaced by right hand side, evaluated afresh each time. That is what the meaning of this. Okay, so you can understand now why it's called delayed. Whereas here it's not so. It is equal, it is different. Whereas here it is completely different. That's the purpose of your left hand side. semicolon equal. Double equal means whenever you are equating an equation. Okay, this is an equation. See, returns, yeah, this is equal to, returns true if left hand side and right hand side are identical. Okay, left hand side and the right hand side are identical. Then there is a list now. I can have a list. This is what actually list. The question mark which we can create a left hand side, where is the list which we have seen here? This is a list here. This is another list here. This is another list. So list is a list of elements. That's all. As it is, it won't do anything. But if you ask to do something within the list, it will perform the operation. So list as it is, it will be listed. If there is an operation is given within the list also, it will evaluate and give the result as in the form of a list. Then you have a functions, various functions that are available. This is cosine function. And what is this cosine function? Details are available. Sine function, exponential function. Then this is the find root. I have a transcendental equation which we are going to see by using the half interval search. Then you use by Regla-Falsy or some other name for that. And Newton-Raphson method. Those methods are available that has been used here to find the root. You can automatically evaluate whenever you have a transcendental equation. I hope that people are aware of these transcendental equations. Okay, if you want to know about it, you can probably click it and go. And we come across that very often in our physics problems. Many number of problems, even classical mechanics, quantum mechanics, many places you do come across this transcendental equation. No way you can evaluate them without having the support of numerical methods. Okay, you have to use only numerical methods. It is not a polynomial where you can find the roots and then substitute it. Okay, then there is a solve. There are options which we have already used for solving it. Okay, so that is can also be explored. We have explored them already, some of them. Numerically also one can solve, where when there is roots that are not available in a closed form, then you can really go for an n solve and substitute it and check whether it satisfies or not. Expand. You can have an algebraic expression that can be expanded. This is connected to the algebra. Simplify, again connected to the algebraic forms that you can simplify them. Then you have a power expand. If you have a square roots and then multiple squares of that or cube, power 4, all powers that are there, power expand can be used and you can expand them and simplify, bring it to a form like. Flattened list of data that are available that can be flattened. Remove all the sets now and make only one list that is flattened. From that one list, you can get back again the number of lists that you want, number of data points or number of each group of list, how many number that you want, that can be selected by selecting the option of n. Okay, suppose I have 1000 data in a list continuously. I wanted to have a 3 data in a set. Then you use this flatten list n. Okay, no, that can be done by flatten and what is opposite to that? I have to recollect that. This is flattening. Okay, this can be done. Flattening can be done in terms of the number of unit in each set that whatever you want, that can be done. And then there is a head also. Flatten expressions with head h. With maybe some naming will be given. And this is the multiple lists that can also be created with the given list. You have a clear statement which you have written. Remove also which we have sent. I think I should suppose to given a clear remove completely from there. That's going to be a problem. So clear would be better. It will be cleared and within the program. Clears values and the definition from the symbol I, whatever you have. Okay, clear form 1, form 2 clears the values and definition for all symbols whose names match with any of these string patterns form. This is the form pattern. Similarly, remove the symbol completely so that their names are no longer recognized by the Wolfram language within that notebook. When it comes out and go back again, it will be available. That's why I think I have given a program with the remove. You just remove that statement, make it as a clear. So don't use remove. That once you enter it, it's going to be a problem. First time it's all right, but when you do it second time and you start performing, then it will not work. Okay, I think I do not know how many of them have tested that, which I have given with the statement remove. So replace that remove by clear, and then put the so-called global and the stars, whatever it is required. So these are some of the things that we have learned so far, and with the minimal thing that we have done lot and lot.
So remove means we are removing one variable.
Remove the variable that is not anymore available there in your notebook itself. For that notebook, it is not available for you anymore. That's what it means.
Can you give an example for that?
For example, I remove the, we'll go to that remove part which we have done it earlier, no? Where is it? I think probably.
Yeah, I'll see that. Okay.
Yeah, I can check it now. No. We'll come back to this probably. Well, where is it? Yeah, remove here, no? This example, typical example. For example, I am removing, just try this. It is working now. It will work now. 21, 22, it's working. Now I will operate remove. If I give this, so it is removing now. It's available. Maybe I have to try here again. But fresh entry might be. I think it is available when you start operate it again. That this is available here. Okay, probably you can try here one more try. What we'll do first, we will go to evaluate fit from local things, which completely remote. Okay, so now I'm entering this, evaluated this. Second one can be evaluated. Then come back to this. Just want to check one more time. Yeah. Working, no problem. Remove. Come back here. Now. I think fresh entry seems to be working. No problem. Maybe that when I typed it, maybe when you enter it back, it is, even though you have removed it, it is redefined here. Therefore, it's available. I think I might have made some mistake there in the symbol here, but it's still working. I don't think it's removing completely. Not removing. Yeah, probably the way I'm trying to demonstrate is not the. Okay. Come back again. If I don't remove it and run it, no problem. If I remove this, remove the thing. Yes, back. Seems to be okay. Well, we have to understand a little more on that again. What is that we are trying to do here by remove statement? But it says that it is being removed completely. But when you redefine it, it's coming automatically, no problem. So then I want to check with the other one. Don't save. What is the other exercise which we have done? No. The thing which we wanted to do now. Where lesson 1, differential integral formula. That's what you have seen now? No. Lesson 3, lesson 2, differential integral form. That's what you have seen. It's working. It seems to be working, but I do not know what is the. Still, I am not able to get the exact meaning of that. But it is better to use clear. I think I have seen somewhere some problem which is given, which I am not able to identify right now immediately. Okay. I think we will, for the time being, we will accept that what has been seems to be repeated. When it is repeating, it is working well. Then we have to really look for the further understanding of it with a specific example where you when you come across the problem. Okay, right. I wanted to close this and come back to this. This is what you are remove and clear. I think you have some more understanding. Clears values and definition of the symbol. Here, remove the symbol completely so that the names are no longer recognized by the Wilson language. I do not know. Maybe here we must have given some typical examples. Trying to remove X. Okay. No, we have not. I say. See, if I remove this X here, that X is not available for you to define again. That's what it means. So it is asking for X now. Missing unknown symbol. Okay, now I wanted to define X is equal to, let me take it as a 10.0, enter it now. Remove X here. Then I ask for that. Yeah, that's right. Now it is being removed. This is not available now. But if I redefine again, X is equal to 10.0, then if I ask for X, that's available. So redefinition is available. If you don't redefine, that will be get removed. It's not available. You get the point now? I hope clear.
Yes, sir. Clear means it is clearing all the variables.
No, it's not like that. That the variables are clear all. That is global, which means all the variables that are defined, that will be removed. Then freshly, if we enter it again, that will be available. Well, let me go back to that again. Yes, I'll go back to that. I'll close it. We'll go to the, okay. Where is the differential integral? How? This is, we will clear it now. We are defined here, and I will go back to that. Remove. If I ask for d of t, not available. That's what it means. Correct? See, we should come back to this again. I just try to explain to you now. Remove everything now. Okay. This is done. This is done. Now I call for the d prime of t. Available? Correct? Now I come back to this. Remove. You ask for the d prime of t. Not available. Get the difference? You can redefine again. But once you remove it, it will be removed until you again repeat the calculation. Is it clear or still you have a problem? I'll start again. Remove this. Run, execute this. Execute this. Now I am asking for d prime of t, which is available for me.
SARS power has gone back. Power gone. Now he is trying to reconnect from his mobile. Please wait for a while. Okay. See, all of you have ordered the Mathematica. You have any problem? Because I entrusted the company official for helping you for that. Anyone has any problem? You can unmute your mic and tell me if you have any. Second thing, we have loaded all the notes and class lectures in the Moodle site. So whoever wants, they can download it and try it. And we have a place for you to, if you have any problem, you can there is something like forum for posting questions and doubts, that if you post any doubt, we someone will help you out to solve that issue. That is also there. No one is telling yes or no.
Yeah, yes, sir. Actually, sir,
Mm.
clarity
Okay.
is not coming. Network
Pardon?
issues there.
Pardon?
Sir, your voice was not coming clear to me.
Ah, okay, okay, okay.
I'm just net.
Yeah, right
Sir, sir.
now, am I audible?
Yes, sir. No.
Okay.
Sir,
What? Yeah, yeah, please
sir,
tell me.
you said the ID and password that is not working. Like I have to put my email
Yeah,
and identity.
yeah, Prachi, you didn't uh, entered in that Google form. That is why your email and the password
Okay,
is not working. But
okay, sir.
if you send your details
And sir,
in
how
the
I will
Google
get my
form,
Google Form, sir? Google Form I
yeah, yeah,
didn't
I'll
have.
send you. I'll send you that. That is why.
Okay,
But
sir.
all the other people who have already sent the Google form, we have created an email address is your username, and password is whatever you had given. Or in general, we give a Moodle at the rate of 123 is the password,
Okay,
and you
sir.
can change it because in that we need a capital letter, a number, and a symbol. That is why in general, I gave the
That's
password as capital M O O D L E at the rate 123.
okay, sir. I have to fill the Google Form first, then.
Yeah, yeah, yeah. I think I have sent you a WhatsApp message. In that, I have given the
No,
details.
I have recent messages only, so I don't.
Uh-huh. And you can enter your attendance also in that Moodle, because finally we will be issuing a certificate
Okay,
uh,
sir.
for that. After 5 classes, we will give a small, simple assignment, because as per the university rule, we have to do continuous evaluation, and that's why.
Okay, sir.
Okay, we will wait for some more of 2-3 minutes more, and I'll call Gigi sir once again.
Okay, sir. Thanks.
Anyone else in the group has any problem like in working with Mathematica? Rauf sir,
Yes, sir.
did you understand what is the difference between remove and
Remove and that one.
clear?
No, exactly not, sir. I have to try it. Then only we will
Okay.
understand.
Yeah, sir is back.
Yeah.
Sir, welcome you, sir.
Or has come back.
Yeah, okay, sir. Thank you, sir. So now your window, the presentation is not on now.
Yeah, wait.
Okay.
Now it has come. Is it okay?
Yeah. Is now it is okay.
Okay, we are trying to explain this one. Remove this global, na? So now it is available, and I enter it now. Okay, it's available because removed it the whole thing. I started freshly defined here. It is available now, right? If I use the statement remove again, and if I ask for this d prime of t here again, I don't get that again. So which means by removing this statements whatever which is defined here, that's also lost. And similarly, you can check with the other things that are defined here. For example, d double prime of t, that is also not available. Okay. Okay. Similarly, v of v of t comma t0, what is being defined there, that's also not available because we have removed them. If you wanted to get it back again, you can go to the statement again, re-enter the things without using this. Now you are getting it back. This is available. This is available. That is what the meaning of that. Get it now? This is available. If I remove, now I am going to remove this, whatever which has been entered so far, remove. Then if I ask for the things, for example, I ask for the d prime of t, not available. Okay, d double prime of t is also not available. And this is also not available. Clear? And again, you re-enter it, things will be available. So it does the whatever which we want that has been done by this remove statement. Remove global things, which means all will be removed, and then see, including this output also disappear because all this defined variable has been removed. Output will disappear. Okay, here also it is disappear because we removed them. Is it clear? If I enter it again, even if you enter it here from the beginning, remove again, then we are freshly entered. Now things are available. This is what the job of remove global things. It is also equivalent to clear also. Clear also similar to this. Only difference is clear means that this variables may be available, but output may not be there. But here also same thing happens. But the variable itself disappear by removing this statement. Okay, I think there is some understanding is clear. Something is we are able to do. Okay. I think you can
Yes,
practice
sir.
it. It will be all
Yes,
right
sir.
when you try to run it. Okay. So this is what the thing so far which we have learned, and we have to really try to practice them and make sure that you are learning each stage of it, where you are having a better understanding towards this lesson. We now in which I wanted to show what is simple harmonic. There is some exercise which I felt I should explain to people now.
So power expand means it is a Taylor series expansion.
No. Series expand. Series is different from power expand. Power expand is something connected to. Okay, where is the power expand? You can see that it's not a difficult thing at all. It's an algebraic form of simplification. Power expand is here. Okay, I just click here. See, you don't have to memorize anything as I said. Okay, square root of xy. X equal to 3. This is what expansion. This is the list which has been given. Now suppose power expand square root of xy with the assumption true, which is taking the floor values. You know what is a floor? That we will be learning it shortly. That can also be used here. But for the time being, that when you have a, for example, square root of, let us take this one, power expand. Yeah, we'll take square power 4 square root. Okay, this is given, na? Is it expanded now? As it is given, na? Am I
Yeah,
right?
as it is given. Yeah.
Okay, now I wanted to add power expand. See what's happening. Is it okay?
Yes.
Yeah.
So now you can see this purpose of that. The series is different. SERIES. Series is, for example, log take x. Okay, x varies from somewhere. Let me take up to 7. So I don't know what is happening here. I do not know how to do this one. So take x to x0 as a reference and then try to take it up to 7. No. Yeah, it's done. Okay. This is series expansion. Up to 7. You can have any numbers. That is different from 20 from power expand. This is series. Okay. Similarly, you can have a other functions like sin x. These are all most useful thing that we will be learning at this stage. This is the sin x. And I can have a e power x. I just simply put e power minus x here.
Sir, if I want to get x minus x cube by 3 factorial, like here there is something like x minus x0.
X minus.
If I put x minus x0 square,
Yes. Yeah.
if I want sin x is equal to x minus x cube by 3 factorial, like that,
Yeah, it's possible.
simply,
Yeah, it is possible. Say, for example, I would want to have a sin x. Okay. Sine of x. I wanted around x0, you expand it for 4 terms. X cube will be there. Whatever. This x0.
sir, without x0,
I'll take it
if
as
I put 0, then
0, you do it, no problem. I have expanded vision. So x and x, because odd powers, no? If you wanted to have a, say, if it's up to 15, then you will get odd powers only.
yeah, we have to put 0 there, okay.
Yeah, that's right. That option. Expand around that point. 0 is around now, is it not? Around that point, x equal to 0,
Yeah,
which you have taken now, and then it has been expanded. This is your factorial terms. Is it not? So even if it is fractions here, doesn't matter. X by 2, x by 3, x power 3, done. Okay? Doesn't matter. Any form it can be taken and that can be used. Similarly, you can go ahead with this cos x. And suppose I have 1 plus x divided by 1 minus x. Expanded. Okay? You know what is the difference? What is there any
so there
mistake
is a
here?
bracket in the numerator.
Numerator
So
is
there is
required,
a
otherwise it will
bracket
be
on the
completely different. Now you see
numerator.
Yes, it should be there. Otherwise, now 1 plus of x divided by 1 minus x. Now you can see the difference. This will be different series. You have a common factor 2, 2, 2, 2, that's missing. You see here, 2, 2, 2, 2 is there in every term. If I don't have this
Yes, sir.
bracket, so this is where you should be careful. Okay, it is equivalent to 1. This is equivalent to 1 plus x divided by symbol is control slash. Okay, this is equal to 1 minus of x. If I don't have this bracket this expression means this. Understand? So you should be careful about it. Now we can see what you have in this result will be get modified. Correct? Add this. Bracketing should be done properly. Okay. Now if I square it, then look at this. Get it? Only even powers you will get it. You don't get the odd powers. 1 plus of all even power with that 2 times. Did you use this somewhere? Shahin, you remember this? We have used somewhere in our classical mechanics course. You can refer.
Yeah,
In a
don't
bouncing
think.
ball problem.
Yeah, okay, I'll see,
1
sir.
plus e square by 1 minus e
Okay,
square.
sir. Okay, sir.
1 plus e, 1 minus e. See, that series has been written in this. This form will be there. We have converted into this equation. This is the form it is
Okay, sir.
available, and we have written in this form. 1 plus e square divided by 1 minus e square, 1 plus e minus 1 minus e. Okay, so that's how it's being. So series is different from the power expand. Right. Okay. This is what your power expand. Platon is yes. There is also. So we'll close this one now. Maybe another 2-3 classes will take, and we anything extra we have learned, we will recollect that. And this also I'll send it to you so that you will know that these are all already being exposed to you to use. All these things have been already sort of exposed to you, and then you are trying to do some computation based on this. So that's why I just compiled them. So for 2 classes, whatever which we have learned, that is so here. So let me try to see the exercise 2, which is sort of, yeah, it's quite interesting problem now. You are familiar with the bungee jumper, right?
Yeah, we have
jumping.
seen that.
Yeah, you'll be jumping from a particular height by using elastic property of the material, and you go up and down, up and down, up and down. Okay, so now the displacement y is given in this form. What is that? 25 meters of cos of pi t divided by 6 seconds. So don't confuse with this 6s is something. This is the seconds plus 38 meters. This is the term which is added. Sketch the y of t from t equal to 0 seconds to t equal to 5 seconds. Calculate the average velocity of the jumper between t equal to 2 seconds and t equal to 3 seconds, between 2 equal to 3 seconds and t equal to 4 seconds. What is the instantaneous velocity of the jumper when he is closer to the ground? Okay. When he is closer to the ground. So now I would suggest all of you start entering it, right? Whatever is given here. Enter that and see that you are able to enter the program and calculating the parameters. Start, do it now. Y of t, do it now. Won't take much time. Type them properly and put the brackets. All things that should be entered properly. Then afterwards, think about the calculation of the average velocity between second to third second. What are you supposed to do? Find out the average or the displacement between these two times. See y of t, that's the only variable you have. Other things are available. Y of 3 minus y of 2 is the displacement between these two times, divided by the delta t. This is delta y divided by delta y is the displacement, not the distance. Please remember that this is the displacement divided by del t. If I do that, I'll get the first part. I'm putting in this curly bracket and then getting the numerical value. These are the things. And put a bracket here And here to write Newton's meters per second, which is a velocity. It's an average velocity. Okay, which is in the list. I'm getting it for the time 2 to 3 and 3 to 4. The time t equal to 2 seconds to 3 seconds, 3 seconds to 4 seconds. Both are the same. I hope you have completed the statements now. Done? If you say yes, we'll go to next. I want to make a table of what?
Yes, sir.
Time versus y of t. What has been given here is average velocity for 2 different times which you have found, or 2 different displacements you have found, which is del y by del t. Del y is the average distance divided by time over which you wanted to find out the velocity. Time taken. Now I am generating the data starting from 0 to 6.5 seconds in steps of 0.5. So now you can see n number of data. How many number of data I am generating? Can you find out how many number of data that is generated now for this range? And how do you find out that? For anything that you do here, what you have to do, minimum value of t is 0, maximum is 6.6. So 6.6 minus 0, put it in a bracket. Bracket should be done properly. If you miss the bracket, you will see the consequence of that. Divided by, what is the increment I am giving it? Is 0.5.
0.5.
So you will see how many number of data. 13 data will be there. Is it available now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, then 14 data are there. Because 0 has also been taken addition to the
Yeah, including 0.
Including 0, now you have a 13.2. Okay, now I have not defined this as a variable here, data set. I can make as a data set 1 equal. If I enter it, I am getting as data set here. So what happened? Well, you know what is the reason here? Why are you getting this one? I am not getting the result. What is the mistake which I have done? Are you able to see the screen? Hello?
Yes, sir.
What is the mistake? Maybe others should also find out and tell me. Because this is equally important to find if there is a mistake, how do I correct it? That's important. I made a mistake here. I'm not getting the data. Anybody see the screen?
You have to define the variable prior to that.
See, this is not been executed at all. Okay, this is an input which is with the star. It's not an input at all. No output is available with this. It is not been executed. So if I enter this now, I'm getting the input and output, that is 3. And this is your average velocity. Again, I'm entering, I'm getting it. Input 4, this is output 4. But this is 2, at that time this is not been done. Therefore, I am not getting these numbers. It has simply given the y of 1, 2, 3 that has been given. If I enter now, I will get it as a data set 1 that is available. I want to know what is the length of the data set. Length, length of data set 1. Correct?
Yes, sir.
If I enter it, what do I get? I have a 14 things are that are available. Just counting, I have a mistake somewhere. 13 plus 1, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 are available now. Previously, I done a mistake. Okay? Is it clear?
Yes, sir.
Right. Now, suppose I increment it to 0.1 or 0.05. So what do? I just take this one, copy, edit, copy, go to this place again, enter it here. I want to have a closer set of data. So I'll just, instead of taking point 0.5, I'll just 0.05. Okay, so that will become how many data I will get it now. I'll define that as a data set 2. This is data set 1, and length has been found. Similarly, I just simply enter this. I have this data set now, and you can see the number of data. Now, we are able to see this screen on the screen, right? And what is the initial value? The initial value is 0, 6.5.
0.
This is 0.05. So how many data should be there? 132 data plus 1, 0th one. Okay, we have to add that. That is the number of data. So now what I will do, I just copy this. Ready? Copy. You don't have to repeat typing again. Paste it over here. I wanted to find out how many are there. What are we supposed to do? Length, data set 2, correct? Because that's what I'm interested to find. Enter it. 133. Confirm. Okay?
Yes, sir.
Okay. Now suppose if I make it as 0.01, what would happen? 661 data will be there. When that is the case, okay, I don't want to see the entire thing on the screen. You see? Why should I see these things? It's not necessary to see. I'm sure that it is working properly because already we are confirmed with the sample data with 4 or 5 of them. Put a semicolon. I don't want to see the output. So semicolon purpose is when you don't want to occupy this screen, notebook unnecessarily, you just close them by putting a output is available as a data 2. For example, I'll call this data set 2. I'm getting it back if I enter this. The output is available, but that is not being seen on the screen. This is important that you will be very often, you'll be using this kind of things because that will avoid your screen occupying so much of numbers. Is it clear?
Yes,
okay. This is clear for you. Now what do I do? I will remove this one. Again, I will put a semicolon here. I will not see that. That's all. Twice it has been taken. Doesn't matter. If you don't want it, you just remove that. That's all. Okay, 661 data which you have. This is an option for you. So you can have a 6,000. Okay, it is all depends on how accurately you want it to have. Depending on the problem, you can select them. Then do the computation as you like. But please remember how to select these data. Now the data set what you have here. Okay, table is available. I wanted to see in a table form. Correct, na? This is not a table form. It is like a list which is available. And each one you can see, for example, I wanted to check data set. First, let us take data set 1. Okay. Whatever the data you wanted to locate, that can be located now. If I say with a single bracket, I'll put a number 4 and shift enter, you just see what is happening. The whole thing will be listed out, whatever you have in the data set 1. Okay. So, which is equivalent to calling the entire set like this. Okay. With a single bracket, if I give any number, you will be getting the whole list. You are not locating now by the process. Now, suppose I wanted to locate some data position, for example. For that purpose, I need to use double bracket. Which means I want to locate some pair. Say, for example, 3 I want to have. 1, 2, 3, 4, 5, 6, 7th one. Okay, I'm getting that. You're able to see that? Clear?
Yes, sir. Yes, sir.
Double bracket purpose will be clear to you now. You do that now. Suppose I add 7, 1. Because it is a pair, no? I want to have a X separately, Y separately, I want to locate it. Is it possible for me to locate that? You just see 1, 7, 1. What does it mean? In the 7th set, I have taken this axis alone. That is first set of data I have taken. You get the point?
Yes, sir.
If I add 2, I am getting the second set of data. The seventh, whatever we have in the list, first one is 3. By adding 7, 1, I am getting the first one. 7, 2, I am getting the second one. Is it clear?
Yes, sir.
Okay. Now, if I add
Yes,
1
sir.
to 3, I 1, 2, 3 by 2, I can take out only the first set and second set. For example, table. Let me try to explain to you. Table, I want to make this is a I. This is a variable. Okay, I'll take this is 1. I'm going to make another table where I am selecting the first component in each one of them, where that is what represented by this. So now I wanted to vary this I starting from 1 to length, because length is given by this 14. I have a 14 numbers of data that are available. In steps of 1 you can go, that automatically will go because only available in the steps of 1. Now let me look at this data. I'm not able to get it. What happened to this? So you have to find
The
out
length, you have to give the data set's name.
why. I'm sorry. It's not come as 14. So this should be length is a data set 1. 14 of them available now. This is what you will get it. You see up to 6.5 has come. Only the one data set, and this is a single list, no? It's not in pair.
Yes, sir.
Okay. This is not in pair. Fine. Now, instead of this, if you know the number exactly, you can give as a 14. That's also right. You'll get the same thing. But this will be always advantage, because when I change the numbers, then I try to have it as a length of that will be taken as this number. Okay. This is 1. I have only one data which I have picked out, because this assigns the, what is that it does? It assigns the row and column like, is it not? There are how many rows and how many columns you have? 14 columns, 2 rows. Correct, na?
Yes, sir.
14 rows, 2 columns. I am just operating through the indices here. These indices are I, where this can be any integer, it can be any variable, doesn't matter, even A, B, C, whatever you like, it can be given. There's nothing like a Fortran, we have IJKL, no such things. I can write it as an R. Okay, just take R as a variable. That's not an issue at all. Okay, I'm getting it. I can have a M, N, J, Z. Okay, let me take it as Z. That doesn't matter. That variable will be taken because it goes in steps of 1 by this data. Is it okay? So we always practice it by using IJK because that's what we will be using for integers, which we follow in our other languages. Okay, this is what the first one. Suppose I wanted to have a second one of list. This is the second one. I want them both together, right? What do? This table, I want to bring both together. Suggestions?
2 semicolons.
No, not 2 semicolons. This you write it, copy, paste again at this point.
Change
Okay, put a comma, make this as 1 and make it in the form of a list. Okay? Right? You know what I'm trying to do? Simultaneously, I am getting this I of 1, I of 2. I varies from 1 to length of the data. If I enter here, I'll get the pair. Understand?
This is the same as the previous
Same as what
one.
you have here. Okay? Suppose independently, if you have been given, you wanted to get this, call them by name, each one of them, and then they get it also. That's also not a problem. Column. You can do very many operations. For example, I have shown you the data which has a 7 columns, 7 rows, 1101 data, rows and columns. The number of rows are 7 and a number of columns are 7. I have a 1100 row. Okay, in that whatever I want to take it, I'm able to take it out by using such numbers. Okay, Where is this? This has an option up to 7. Suppose if I add, for example, data set 1, 3, 3. What would happen? Don't forget to add double brackets. It's important when you are operating on this data sets. What will happen now? Do you get an output?
No output.
You will not get. See what happened. Part 3 of that is not available because there is no 3 in each set data set. I have only 2. 3 is available, that will be given. If it's not there, it says it does not exist. So then what is available is only 1 and 2. It is available. It is available. Okay.
Yes.
So this is how we will be operating the data sets when it is generated for such function. I have able to generate it and I have a list that's available as a data set 1. Similarly, data set 2 also you can check it now because it's going to be a only increase of number now.
Yes.
6,600 doesn't matter for me. 6,601 data will be there. So same thing. I mean, if you have a 6,000, 60,000 doesn't matter for us. Just change this number size and take it to the length of the data set. That is how I handle that numbers 1,101 data sets. Okay. So when you have such things, try to operate with small numbers which is generated. Make sure things are fine. Then you are sure that you can operate by taking any number of any length of data. Doesn't matter for me. And each set I can have a 1, 2, 1 week, from 1 onwards you can have 1,500, 400, whatever is the number that is available, that can be handled. That's not a problem. Is it okay?
Yes, sir.
Fine. So now we can go ahead with the numbers that has been found. Now data are available. So now,
Sir, can I ask one question?
yeah, please go ahead.
If you're storing this data, is it possible how to save this data in array form in some notepad or something?
Export. Yeah, you can. I'll just show you that export statement. As I said, now you don't have to ask this question. This is what I'm trying to say. Look for this option. Now you wanted to have saved all the data in a data file. EXPORT export. Look at this export options. Give the names and identify them, and then data format whatever is available that can be explored. You can see the data format that are available. Okay?
So we can change the format also anytime.
Any format which is available with any of this data which you wanted to use it, that can be done. Pictures can be exported. GF files can be exported. Okay, all possible things that are given. So therefore, that option is enormously available. Data export that are enormous things that are available for you to do that one. So that you learn it after some time, you can learn. Okay, otherwise you can practice, look for such things. So exporting a data, what is to be done in Mathematica, because you know all this Mathematica is done with the square brackets. There are in between there is a data array expression that whatever is available. Okay, that formats, everything is available. Format should be given. So you try to see that one simple set of data you create it, export it, then again import it back, whatever the command is required, practice it. And it is valid for any type of a data, okay, and any number of data. That's also not a problem. So you can practice. It's not a big deal at all. You just see what you are trying to say is that look at things computationally. I need that data available for me to other formats. What do I supposed to do? Then you put the question into the Google search or Mathematica itself and search for it and try to do that. Okay, now let's come back to the problem. It's quite interesting problem to look at it, but this is what your y of t, that we have generated the data of the type whatever we like it, and we have taken a derivative of that. What is the derivative of this? Y of this, which is being given here as this, and I am trying to find out y prime of t. Okay, hello, y of t.
Yes, sir.
Yes, sir.
This is what my y of t. Derivative of this is a constant which goes to 0, and cos becomes minus sign. and there is some factor is coming there that is available here as a 1/6 of that 25 by 1/6 minus this pi will be appearing. This is an amplitude for the sine pi of pi t by 6. So this is what y double prime, and go back to the y double prime. Okay, that is again different. This is being differentiated again. That gives the acceleration. So this is the displacement when he is jumping, and this is the velocity. This is the acceleration. Okay. At the time t equal to 6 seconds, what is happening? Something happening. Velocity goes to 0. What does it mean? Look at these numbers and can you make out some information out of this? What is the physics that you would like to give out for the t equal to 6 seconds? When the displacement equal to 13 meters, for example, okay, 13 means you are above the ground level, is it not? Right? Because you are jumping from particular height, no?
Yeah.
Yes, sir.
Then you are coming down and then around this 13 meters above the ground, this goes to 0. Velocity goes to 0, which means velocity should take a other direction afterwards, is it not? It is coming down here, displacement, and this is the minimum thing that is going to happen. This is going to be the reversal of the velocity. Okay, started and it's going up. This can be seen. And where it happened, that how do I identify that? Just by solving this equation. Find root. You can see this is the y prime equation is this equation, right? And what time it goes to 0, of course, by looking at it, I can tell because when t equal to 6 sine pi, which goes to 0, that I'm able to identify it and then say that this is what the place at which your velocity goes to 0, displacement has a 0 slope. This is what your acceleration curve. Now, if we start repeat these plots, what I have then velocity, displacement, velocity curve. You see that does touches. Suppose if it is -6, you know what will happen? Huh? By 6 seconds, if it is a minus, it is a -5, -6, you know what would happen? You would have died, is it not? Is that right? Because he has touched the ground and he is supposed to hit the ground. Huh? Correct? No. You would have died. So you can see that these parameters should be taken fair and then all that you need to have that should be satisfied consistently so that
Yeah, that is bungee jump.
yeah,
Jumper has to. Okay,
yeah, this is
okay.
a jump
We
no,
didn't,
from
initially
bungee
we didn't
jumper
understand.
is coming down and then it should not touch the ground. This is the maximum height he has started.
Okay, sir.
If it hits the ground, then you see the hell. Okay. So now you can see that will be get repeated here when you go from t. Okay, t I have taken. Okay, let me enter these things now. I have to enter the y prime should be found, has been done. Y double prime has been found. All the three has been calculated, and this is what that you will be getting it up to 10. What happens to this y and y prime t varies from 0 to 100. I limited the range of plot range. Now I go to here. You can see it's nicely going up and down, up and down, up and down. Now there's no loss of energy. It's an elastic thing which is periodically getting changes. You follow what I'm trying to say? I'll put it up to 50. Let me take down t. Or you can take something like a 40. This is going up and down, going up and down. What I have shown up to 10 means it's coming down and going up. Okay, you can see whenever this points is the velocity. Okay.
So there would be some damping also.
It is.
That you didn't
slowly
consider.
it will drop probably.
Yeah.
But dropping has not been accommodated. It has not been shown here. Doesn't reflected here. So it's no way. It will just simply repeating with the same oscillation. Somewhere damping should be taken into here. The damping must be very, very small, so that it will maybe after say a few jumps, he will slowly will be coming to rest. Okay, so that's what should happen. So now we have plotted this, all the three of them, and all the three are interconnected. And that is what the result that you have. And there is a one interesting observation. If you integrate this y prime from 0 to 10, what would you get? Integrate y prime.
You will get the position y.
Displacement you will get, is it not? Correct?
Yes, sir.
You have a velocity curve, you differentiate with respect to the time or integrate with respect to the time, y prime, you will get a 0 to 10. This is equivalent to the value of the function at the endpoints, 0 and 10. Y10 minus y0, I am getting the same thing. You can see integration of a derivative in a limit t equal to 0 to 10 is the displacement. Integration of the derivative y prime in the limit t equal to 0 to 10 is equal to the value of the function at the endpoint. This is one of the most fundamental theorem which is connected to the derivative and the gradient. You remember these relations?
Yes, sir.
The most exciting thing that fundamental theorems of derivative or a gradient says that integration of the derivative or a gradient in the limit, okay, from these variables, lower and upper limit, equal to the value of the function at the endpoints. That is true, which is clear here. That's the message which is being obtained because the integrations with respect to the function, because this is the integration of the derivative, is equal to value of the function at the endpoint. And this is the satisfying means there are many things, conservative force, all this information that can be explained. So find root also has been used here, and this has been done. This is an interesting problem. Now I'll send you this problem again to you people, and then try to explore additionally whatever you wanted to explore that can be done with the help of this equation. And select some such problems. As I said, I think I wanted to give you the reference for you people. Where is it? Yeah, maybe I will add that reference and give it to you. I send it. Okay, where the basic physics books for scientists and engineers, where you find such problems. There are quite a few interesting problems to think and answer. That they are really make you to understand things, and then computationally, if you start think it, and then connect them, you will have a great depth of understanding. You will get it. Okay, so this is what thing which I felt I wanted to share with you. And tomorrow we will work on the exercise on the simple harmonic motion. I do not know how many of them made an effort. Some of them have made an effort to plot them. The most important thing in physics is this simple harmonic motion and damped simple harmonic. I hope that I'll just give you the input now. At least those who are this problem, you remember this? The first problem which I give an external structure.
Yes, sir. Yes, sir.
Did anybody produce these results? Nobody has done it. Okay, it's fine. But you see how exciting is this one. You can derive every one of them within no time. That's where the Mathematica thing is going to help you. And if I take it to the problem to the damped harmonic oscillator, again, same thing can be written. I can make it as a damped harmonic, set the equation and solve with this. Okay. Maybe I'll send this also for you people, go through them. And when I explain in the next class, probably you can understand. But before that, I want you people to make an effort, define all of them, like I wanted to show, because I don't want to send it right now. To define with the list, what are the things that I need? M is given already, correct? Force constant is given. Initial position is given. Velocity is already given. Find omega because it is connecting k and 1, it's already available. A is already given. It is an amplitude which is connecting to the x and the your initial position, initial velocity. Please note that this is x square, displacement square, plus omega v naught square divided by omega square, also displacement. Do you understand what I'm trying to say? Okay. Is this displacement or not?
Yes, sir.
It is displacement. Please remember that, because it is a 1 by f t, that time it cancels and you will end up with the only the displacement line that will be added along this. Take a square and it being added. So V naught square divided by omega square is the important quantity. And this you should be in a position to derive from what is given. I want you to think about how to get the A value in terms of the initial position and the velocity. This is important equation. Okay. Next is you have a pi. This r tan. This also you should be in a position to derive. It's not a difficult thing at all. So now by giving the other values, omega I can found. This has been already calculated because it's equal. Then A is again calculated because x0 is available, v0 square is available, omega is also available by now. If you make the statement other way, then it's going to be a problem. This is not available for this to execute. So therefore, put it in an order where the parameters required is equal in such a way that they are all available by the time when you reach this equation. When I put this here, then we write an omega at that time it's not available. So to avoid that confusion, what you have to do, just make sure that what is needed for each expression should be available previously, that should be defined so that the list will work properly. Then pi, v0 is available already, x0 is also available, omega 0 is also, so that will also be evaluated. You can see the numbers here, 1.752, 0.125, then 1.25, this is the omega, this is 1.2957, then this is the value of the pi, which is the phase in phase. This is the solution what has been given here. This is what the solution. This is what your x0 and v0 on A has been given, pi has been given. Don't accept things as it is. Try to look into it, spend your time, get an idea. See, look at this argument. Does it have any units? Does it have any unit? It must be dimensionless. You can see displacement divided by what would happen to this? Velocity has a time. Okay, then what happened to this? This must be the velocity by velocity, is it not? X0 divided by of time because omega has a time, 1 by time.
Yeah.
So when you look at things like this, you are sure that you don't have to even remember that automatically you will try to understand things. Okay, and here again, as I said, no, this is also, you can look into it carefully. These are all very important things that when you try to look at these things, you have to understand like this. When you understand like this, then what is happening when you try to compute them also will consistently will go. Sometimes you miss the square root. Without square, if you give here, it's going to be an issue. Okay, you may not even know that if you and the omega is without square root, doesn't make sense. Okay, omega square makes sense because that's going to be k by m. Okay, so like this, you have to really think about it. Then make sure that dimensionally also things are coming out properly everywhere when you define them. Now you make a plot. This is x of t. This is the derivative. P of t. I have this relation. You can extend your time limit because it's asked for up to 10. You are plotted up to 10. Then I have a energy of mv square of kx square, the total energy. So I have a kinetic energy, potential energy, total energy. Plot that. You can look at it, what is happening. So this is your kinetic energy. This is your potential energy. The total energy is constant. What does it mean? Is there any physics behind that? That can be understandable. Make a phase space. Phase space or a phase space. X of t versus V of t. This is a parametric plot. It is going to be a circle. Circle makes sense because of the simple harmonic motion. Sine and cosines are involved in the x and t. Therefore, cos versus sine is going to be you can see this is cos sine. It's going to be a circle as long as energy is constant. Energy is not dissipating. So there is no dissipation of energy. Total energy is always shared between the kinetic energy and the potential energy. Take at any point in this curve, add them, total will be always constant. This is the square of that. That is why it is above the x-axis. Negatives will not be seen. Whereas here you see plus minus. Plus minus, plus minus. Okay. So this is what the problem that they are asked for it. And they suppose, you look at the beauty of it. I am decreasing the velocity and the displacement by a factor of exponential minus a. Okay. Every time I have a consistency, only the radius of the circle gets changes, but it is always conserved. Of course, velocity is decaying, it loses the energy. Then you can see that is getting depressed here. This is the velocity axis. Of course, energy is lost through the potential energy. This is what will happen. It is going down. This is what is being maintained. Okay, which means amplitude variation, which is occurred here by this, and this is what the thing that happened. And put them together, this is what will happen. Okay, then if there is a damping, for example, you plot the potential energy versus kinetic energy. The velocity displacement is a circle, but when I plot kinetic energy versus potential energy, it's going to be a straight line. This is very, very precisely conservation. Okay, when this is large, this is small. When this is large, this is small. Total will be conserved. Okay, that can be seen. And of course, we can animate them also. Okay, I want you people to make an effort. Next class, I will explain one more time. In addition to this, we will learn additional things. Anyway, you can define all these things with an arrow. Do the computation again. Same thing will be getting it. Okay, so I want you people to understand this. What do you mean by such things, and then how do you substitute it back? See, I'm getting the same result. Absolutely no way it's different. Then try to take it to the famous problem of so-called damped harmonic oscillator and forced damped harmonic. They're all amazing. That still there are wonderful things that are existing with these things. Okay, so we will learn there are additional things along with that. And this is what I felt I should. Though it is a simple, but it has a fantastic physics which goes into this. Okay, so I'll stop here. And if you have any questions, couple of questions, and then we'll go ahead with the tomorrow's class.
So tomorrow we need a holiday because tomorrow there
Oh,
is
that's
a,
fine. Tomorrow you need a holiday. Why? Anything special?
because in department there is a seminar, so students.
Okay, okay, no problem. So you turn to the other members and tell them that
I'll convey them. Okay.
we can
So
have it
then
on
we will,
Wednesday.
Yeah, Wednesday. No. Tomorrow is Wednesday. We will have it on Thursday. Yes, sir.
Okay, Thursday we can have it. No problem. Absolutely no problem.
Okay, sir.
We can have it on Thursday afternoon, same time.
Yes, sir. Same time.
Okay, I'll send this things now. Do you need
Yes,
this
sir.
now, or you wanted to have it?
Sir, it is better if you send it today.
But you people will not make an effort to produce them. Anyway, I'll send it now.
Yes, sir. Yes, sir.
But you
Yes,
just
sir.
make sure that you are trying to do. Maybe you can generate the data and make a list plot. That's additional thing you can plan. These are function as we have plotted now. And one more thing, what I have given, I forgot to tell you that. You can see here, introduce this D-solve. X double prime, which is a double derivative, omega square x of t equal to 0. This is what your simple harmonic motion equation. Okay, this is like d square x by dt square, and this is x. Omega square is this k by m. This is the initial condition for the displacement and for the velocity. Find out x of t, t is a variable. This is what the result that he has given it. Correct, na?
Yes, sir.
Yes.
Over. I'm able to get the result directly with one line. Okay. So now, when I know this one, I take a differential of that. I'm getting this velocity. So at time t equal to 0, I have this so-called initial conditions for the displacement a cos pi minus a omega sin pi. That's also available for me. Then you solve this equation. I'm getting a, and pi again solve this. So all information what has been given as a problem, you're able to derive it also. It's available up to this. Afterwards, we have generated. Okay, so I have given that also. Please go through that. How to give a differential equation statements The simplest, everybody is aware of that simple harmonic motion equation. This is what your equation. We need to have two constants. The two constants are the one initial displacement and initial velocity that are also given in terms of the initial phase. Then we are looking for a solution x of t. T is the variable. And then we are looking for the solution that I am able to get it. Derivative is the velocity. Over. All other things are available. And this is what your real physics. And when you have a multiple, suppose this amplitude changes, the radius is changing, that each one of them is an equation of a simple harmonic motion, and corresponding solution has been found, and they are all consistently varying. If it is a damped harmonic oscillator, what will happen to this? That you can think, and it has also been think about it. And if it is a post damped harmonic oscillator, what is to be done, that also can be planned. Okay, save. I send it. Any other questions do you have? Any questions from any other members? I do not know how many of them are sitting till the end of the session. Only 20. So about
So
90
right
people.
now some 5-6 people left. Just
Okay.
5
So
minutes back.
till the end of session, how many are there on an average? 25?
25, sir.
Around 25. Okay. 25 is a good number. If all of them are sitting and listening, they have made an effort. That would be nice. Okay. So we can meet on